However, it is also pertinent we talk about duration. You know, when I'm talking about duration, forget that we had treated that. We just want to relate to the conversity that we are currently treating. So bond duration measures the change in a bond price when the interest rate fluctuates. You still remember that? So if the duration of a bond is high, what it means is that the bond price will move to a greater degree in the opposite direction of the interest rate. Opposite direction of interest rate, meaning that if interest rate is going up, the bond will move to a greater degree in the opposite side. Understand? And conversely, when the figure is low, when the bond duration is low, the debt instrument will show less movement. So duration, if duration is high, it means that the bond price will move to a greater degree in the opposite direction of the interest rate. So it's the duration that shows the extent of movement or changes in the bond price to changes in the interest rate. And typically, if the market rate rises by 1%, a 1-year maturity bond should decline by an equal 1%. However, for the bond with long-dated maturity, the reaction increases. In other words, if the rate rises by 1%, the bond price falls by 1% for each year of maturity. For example, if rate rises by 1%, the 2-year bond price will fall 2%, the 3-year will fall 3%, and the 10-year will fall 10%. Understand? I hope you have not confused with what we said earlier under duration. It is the same thing we are still saying. If the duration is 4 years, what it means that the bond price that happens to be, if duration is 4 years, for 1% changes in interest rate will lead to what? 1% changes times 1% times 4 in the price of the bond, which is what? 4%. Because duration is 4 years, it's treated by 4%. If duration is 5 years, the price of the bond will change by 5%. If duration is 6 years, the bond will be 6 years. So what you have to hold here is that when you are told that the duration is so years, and what is the changes in the bond price, just make sure that years we change to percentage, because 1% multiplied by the year will give you that year percentage, 5%, 6%. So 6% of the bond price will change. If the interest rate increases, the bond price will reduce by that 6%. If the interest rate reduces by 1%, the bond price will reduce by that percent, and vice versa. Please do not just get confused. That's on that. Now, let's look at the conversity and the risk. Conversity builds on the concept of duration by measuring the sensitivity of the duration of a bond as yield changes. So I said the yield is the income expected from a bond. Now, conversity is a better measure of interest rate risk concerning the bond duration. And when duration assumes the interest rate and bond price have a linear relationship, conversity allows other factors and produce a slope, that is curve. As before I go further, now duration can be a good measure of how bond price may be affected due to small or a sudden fluctuation in the price. However, the ratio between the bond price and yield is typically more sloped or converse. Therefore, converse is a better measure for assessing the impact on bond price when there is a large fluctuation in the interest rate. As conversity increases, systemic risk to which the portfolio is exposed will also increase. Look at the relationship now. The risk and what? And conversity. They are positively related. The higher the risk, the higher the conversity, or the higher the conversity, the higher the risk, because it's the conversity that determines the fluctuation in the bond price. Now, the term conversity became common during the financial crisis in 2008 as a failure of one financial institution threatened others. However, this risk can apply to all businesses, industries, and economic as a whole. The risk to a fixed income portfolio means that as interest rate rises, the existing fixed rate instruments are not attractive again because they become down. As conversity decreases, the exposure to market interest rate decreases, and the bond portfolio can be considered hedged. Typically, the higher the coupon rate or yield, the lower the conversity. The higher the what? The higher the yield, the lower the conversity. Understand? The lower the conversity, or the lower the market risk of a bond. This lessens the risk is because market rates will have increased greatly to surpass the coupon on the bond, meaning there is less risk to the investor. That's on that. Now, let's now look at negative and positive conversity. What we really mean when we are talking of negative and positive conversity. If bond duration increases, the yield will increases. How the yield will increase? If bond duration increase, as yield increase, let me come again. If bond duration increases, as yield increase, the bond is said to have a negative conversity. Increase in duration and increase in bond, meaning negative conversity. And in other words, the bond price will decline by greater rates with a rise in the yield than if the yield had fallen. Therefore, if a bond has a negative conversity, its duration will increase. If a bond has a negative conversity, its duration will increase. Please, I'm hammering this area because these are the area where the multiple choice can come, the objectives, for them to test the knowledge of this part. That's why I'm bringing them out for you one after the other. I said if a bond has a negative conversity, the duration will increase. And if a bond duration increase as yield increase, the bond is said to have a negative conversity. Understand? Therefore, if a bond has a negative conversity, its duration will increase. The price will fall. Duration will do what? Will increase. The price will fall. If the duration increases, the price falls. As interest rate rises, and the opposite is true. That is, as interest rate rises, when the interest rate rise, the bond price will do what? The bond price will fall. Now, if bond duration rises and the yield fall, if a bond duration rises and the yield fall, the bond is said to have positive conversity. If as duration increases or rises, the yield falls, the bond is said to have a positive conversity. In other words, as yield fall, the bond price rises by greater rate or duration than if yield rose. Positive conversity leads to a greater increase in bond price. If a bond has a positive conversity, it will typically experience larger price increase as yield fall. Larger price increase as yield fall compared to price decrease when yield rise. And under normal market condition, the higher the bond rate or yield, the higher the coupon rate or yield, the lower the degree of conversity. That's a normal situation. The higher the coupon rate or yield, the lower the conversity. And in other words, there is less risk to the investor when the bond has a coupon that is higher or yield that is higher, since market rate will have to increase significantly to surpass the bond yield. So a portfolio of bond with a high yield will have a low convexity and subsequently the less risk of the existing yield, becoming less attractive as interest rate rises. I hope you get all these things we are trying to say. And consequently, zero coupon bond have the highest degree of convexity. A zero coupon bond has what? Highest degree of convexity. Zero coupon bond has the highest degree of convexity because they do not offer any coupon payment. For investors looking to measure the convexity of a bond portfolio, it's best to speak to financial advisor due to the complex nature and the number of variables involved in the calculation. So that is on that. I hope you have gotten little regarding bond convexity. Now, before we round up this section, let's look at the bond convexity formula. As you can see on the screen, convexity is equal to 1 all over P multiplied by 1 plus y bracket square into summation CF is cash flow all over 1 plus y raised to power t into t square plus t, where P is the bond price, y is the yield to maturity in decimal form, y is what? Yield to maturity, which is the rate, and t is the maturity in year. This t is maturity in year, and CF is the cash flow as time t. And convexity adjustment is equal to convexity multiplied by 100 multiplied by changes in the yield square. Now, let's look at this example. The bond price with face value, the value of the bond is, face value is 1,000 with a semi-annual coupon rate of 8% and a yield of 10% and 6 years maturity, and the present price is 911.37. Duration is 4.82 years. The modified duration is 4.59, and the calculation of convexity will be as follows. Let's look at this table. Now, from the question, we had that the coupon is 8% and it is semi-annual, meaning that it is 4% per annum. 4% multiplied by base value, which is what? And that one gives us 40 naira. That's why we get this 40 naira for 6 years. These are the interest for 6 years, which means 12 times. And at the end of the year, it is settlement of the debt that make it to 1,040 naira. Now, the present value of the cash flow, at what rate? We are told that is at the yield is at 10%. So 10%, don't forget the way we calculate the yield. Sorry, the present value. The present value is calculated by saying the cash flow all over 1 plus the yield raised to power time. And for the first one is 40 all over 1 plus. What's our yield? The yield is 10%, but it's by annual. So it will remain 0.05 raised to power 1. The first period is 1. And that one will give us, please press your calculator to confirm the figure you are looking at on the screen. So it gives us 38.0952, approximately 38.10. That's why we got this. And for the second time, see this, all this one, these are the time. This is the first 6 months, the second 6 months, third 6 months, fourth 6 months, up to the 12th 6 months. So the first 6 months is considered to be first year. The second 6 months is also considered to be another time, which is 2. So for the second one will be 40 all over 1.05 raised to power 2. That's the second time. So that one gives us 36.28 approximately. The third one will give us 40 all over 1.05 raised to power 3, and that one gives us 34.55 approximately. That's how you continue till the end. And we are talking about the weight. The weight is equal to present value of cash flow divided by price. That is the weight. Weight is equal to present value, which is 38, divided by price. And what is our price? We are told that the price is what? The price is 911.37. So 911.37 divided by 38, 938.10 divided by 911 point give us what? That one give us what's the price we have there. Let's get the price correctly before we determine what the answer is. Our price is 911.37. So if that is the case, we have 38.10 divided by 911.37. So it gives us 4 price weighted multiplied by